Hello, this is my video for project 2. I'm going to start out with the code implemented like the pseudocode in the assignment. So you can see I'm starting out with some constants that define the ranges for the randomly generated values for k, the index, and t, the delays. Then we have n here, which is the size of the static mutable buffer below. So this is the shared buffer that's used between the two threads. Then we have the function that defines the producer thread. Again, implemented just like the assignment said. And you can see here where we're using this static mutable buffer. You can see this is enclosed in an unsafe block, because if I were not to have that, you can see that Rust Analyzer starts complaining a mutable static is unsafe. So you have to actually have that in an unsafe block to get that to compile. In the consumer thread, again, it's implemented just like in the pseudocode. So nothing really to explain here. Again, you've got your unsafe blocks, and then we're just we have a function here to display the contents of the buffer, and we also have the producer and consumer threads just being spawned here in the main function, and basically just looping forever. So if I go ahead and I just run this, you'll see that it's going to have a delay as these two threads do their thing, and eventually it's going to come back and say there's a race condition detected because one of these conditions it was met. Okay, so there you go. It says producer's too slow, and you can see that buffer just kind of continues to update. It just loops forever. So that's that. That's bad code. That's really not something you really want to do. So if I switch over here to my main function, I'm just going to go ahead and uncomment that. I'll comment this out, and then I'll come up to the top again, and you can see we've got similar stuff going on here. We got our ranges, we have our const in there, but we don't have that mutable static. If we come down here, you can see that here is our buffer, and you can see it's wrapped in an arc mutex, so that's to ensure that both threads can't access it at the same time. And then we have this S value that's also wrapped in an arc mutex. And then these mutexes are just fed into these functions as it spawns a thread. I did make some changes to the logic here. I didn't really want to exit the process if a race condition was detected, because I was troubleshooting this. Also, I would say this. I don't really understand why you would have random indexes. I'm actually programming something very similar to this. I've done a lot of programming like this, like serial communication. I'm programming an RF comm thing at work right now. It's over Bluetooth. So anytime you have a buffer that you're writing to from one place and reading in another place, it's always FIFO or something like that. You have an ordered way of inserting and removing data, and you always consume what is produced, all of it. You don't just generate a random value. So I don't know if I'm not sure what the intention was in this assignment. If you wanted me to redo everything, I didn't do that. But what I did was I implemented the mutexes, I implemented the S value. You can see we check against the S value as soon as we establish the mutex lock to make sure that we're not going to have an S value greater than the length of the buffer. And you can see that we also do the same thing on the consumer tag. We make sure that that S value is greater than 0 before we try to consume anything. And then we have the decrements of the S value here, and we go back up to the producer tag. We have the increments of the S value there. So nothing much more to explain. I'll go ahead and run this, and you'll see. Oh, I think I need to write that, and then I run it. There we go. And you can see it just alternates back and forth between producing and consuming. Eventually, this will result in a logical race condition, although a technical race condition is avoided because you don't have it writing to two threads writing to the same memory location.